Hi, and welcome to my session about how Delta Lake with Azure Databricks can accelerate your big data workloads by 100x and more. My name is Kyle Weller. I'm a program manager on the Azure Databricks team at Microsoft, and I'm super pumped to be here with you today to discuss some new and exciting innovations that can increase the performance of your Apache Spark workloads and ultimately save you on cost as well. Let me start by highlighting the key components that I'm going to cover in our short time together today. First, I know you're here listening because you have data, a lot of it, and you want to make use of it. The first step in your journey is to get this data into a centralized data lake on Azure. Maybe you're thinking, well, we have a data lake, but it has a lot of data in it, but it feels more like a data swamp. It's unreliable, hard to govern. It takes a long time for my data engineers to extract any value out of it. If you're thinking any of these things, it's probably because you haven't used Azure Databricks with Delta Lake yet. Delta Lake we will dive deep into on our first topic, but it can truly transform your data lake into a reliable, manageable, and high-performant data lake with this structured transactional layer. Delta Engine, the next component we'll talk about, is a brand new low-latency query engine developed by Databricks based off of and 100% compatible with Apache Spark. With these building blocks combined, you are able to perform high-performance advanced analytics at scale for virtually any use case in any industry. Alright, let's dive into Delta Lake and talk about what it is under the hood and why you should care. First off, some people can get confused by the name at the beginning and think that they have to store their data in a new location. This isn't true. You keep your data in the same storage of your choosing. Azure Data Lake Storage, Gen 2, ADLS Gen 2, Blob Storage, etc. You can think of Delta Lake more as a storage format technology. You can take data from any format, CSV, JSON, Avro, Parquet, and upgrade this to the Delta format. When doing so, what we do under the hood is save this data as version Parquet files, build a transaction log, and add additional indexes and stats. Let me tell you about the benefits. First off, think about the promise of a data lake, the central source of all data democratized, shared, and accessible by employees across your whole company. Traditional data lakes and Spark offer no concurrency capabilities, but because we have version files and a transaction log, we can promise ACID transactional guarantees. This enables simultaneous concurrent reads and writes on all of your data. Another problem with traditional data lakes is that things start to get messy. Delta Lake offers various levels of schema enforcement and evolution control, allowing you to set guardrails, but also still be flexible when you need it. We offer you efficient upserts with blazing fast and simple merge and insert commands. With version files, you have the ability to even travel back in time and reproduce data or immediately roll back to a prior version without reprocessing your entire data set. The next two benefits are uniquely available in Azure Databricks, and I'll show you on the next slide how you can achieve up to 100x performance with these features alone. Actually, before we get to the performance features, let's go through the recommended architecture patterns with Delta Lake at scale on Azure, just to make sure that everyone's on the same page together. Of course, we start the journey with a wide variety of different data sets. These can be structured or unstructured data. The first step, of course, is loading that raw data into our Azure Data Lake storage. Whether it's real-time streaming data coming through with the Azure Event Hubs or something like Kafka Real-Time Messaging Bus, or you're leveraging a tool like Azure Data Factory to ingest data in bulk into Azure Data Lake storage. You get it here in this raw format, and your second step then is going to you can combine streaming and batch with Azure Databricks. You can use Azure Databricks to then save it as the Delta format. It's important to do that in step 2 without changing any of the business logic or without adding business logic or aggregating the data or manipulating the data in any way. Because now what you've created is a Delta replica of your raw format that has amazing performance and access benefits. So you've enabled concurrency control on your raw data. you have a lot faster access. I'll show you in the performance slides how this comes alive. But now you've got that in your raw format that you can always go back to, and it's there in Delta. So the next step is to join and enrich, clean, transform, start diving into that data, develop and train and score machine learning models, leverage Azure ML or ML Flow, and you kind of have this progression. You build a pipeline of this data that we kind of call this bronze, silver, gold design paradigm. There's not necessarily 3 steps that you have to go through. But it's this idea that you start with data that's raw and you start incrementally cleaning it up, because now you have checkpoints along the way as well. Some people may need access to the data as it came in, and that they'd go to the bronze table. You may have some more BI analysts that want to come in and they need clean data. You don't want to make them have to go through a whole bunch of messy, unstructured kind of data. They want clean data. Maybe you're sending them to the gold tables. So you kind of have that flexibility. Then from there, after you've gone through these steps, you can send that data downstream to a Cosmos DB to power real-time business apps. Or you can send it to Azure Synapse Analytics, our next-gen SQL data warehouse with amazing warehousing technologies and really enterprise-scale BI solutions achievable with that integration. Of course, we have native connections and integrations built with Azure Databricks and all the other Azure services on the Azure portfolio. So this is truly a first-party product that you can feel while you're using it connected to the rest of the Azure ecosystem. All right, let's move on to performance tuning, what I know you're super excited about being here today. Everyone already knows the basics about partitioning and how you can partition on low cardinality columns. You're trying to aim for about a gig per partition. This is basic 101 Apache Spark. You should be partitioning your data. But now I mentioned that there's 2 additional features with Delta Lake that are uniquely available for Azure Databricks. One of these is called zorder. It's a command that you can specify in the code where you say zorder this data. I'll show you in a demo coming up real soon. It's a technique that co-locates related information in the same set of files and enables this concept of data skipping. So you're doing this on high cardinality data. So now imagine you've partitioned on low cardinality into groups of files, and now you zorder within those files on high cardinality columns. So you've got this multidimensional partitioning scheme that really makes for fast access of your data. The other command that I'll call out here is called optimize. And this is a command that runs in the background. You can run it on a separate cluster. We recommend F for FSV2 series. You can run it in a separate cluster at your leisure on your schedule. And this command will run in the background and reorganize and compact your data in the perfect size files for high performance Spark compute. So there's this problem with Apache Spark called the small files problem, where over time your data, as you're working with it, starts to be split out into a large number of small files that makes it slow to access. This command will run in the background, compact that all together, and make the performance really optimum for what Apache Spark needs. Now, we have real customers using these best practices today, just these alone, and achieving up to 100x faster processing times versus open source Apache Spark that you might find available in other products. So let's make this come alive in a demo. All right, switching over to the browser for this demo, I'm going to show you how Azure Databricks can quickly and easily run analytics on some COVID-19 data that was made accessible by Johns Hopkins University. And at the end, I'll show you how leveraging Delta Lake can do this same thing and speed up your queries by about 20x is what I achieved here in this demo. So this notebook is available on my personal GitHub. Just follow this short link that you see on the screen there, and you can find this notebook in full. You can dive into all the details. You'll see I'm running some sub notebooks and hiding away some nasty spaghetti code as well. But you can get these notebooks, download them, try them out for yourself, and do that on your own time as well. Keep in mind as we go through this, I'm not a scientist, an epidemiologist, or an expert on this topic in any way. I'm just, a normal person here using this data set that was made available to us.Maybe there are some experts out there watching. Maybe you can leverage this notebook and make an impact on this global pandemic that we're in. So this demo leverages, like I mentioned, some data made available by Johns Hopkins University. You have access to this data for free on any Databricks workspace that you create. When you create an Azure Databricks workspace, it creates a default storage account that we name the DBFS, Databricks File System. And here I can run this fs magic command to ls the demo datasets that are available by default in the root folder here. So if I ls at Databricks datasets, you'll see a long list of demo datasets that you're able to take advantage. Up on top here in this COVID folder, that's what I'm using for this demo. And you can imagine this data has been sourced from all over the world, from various universities, medical facilities, all kinds of different institutions have come together and to share this data that data scientists can collaborate on. And so the first thing that I do here, I actually skip past this command. It's basically munging and bringing together and merging a variety of different data formats and types. And I just pulled it from January through May. It goes even beyond further. It goes all the way up till today. This data stays up to date, and you can come and continue using it. The first step that I'm going to do here is inspect the data that's available. So in my ETL process that I've hidden, I made this temporary view called JHU Daily COVID, so Johns Hopkins University Daily COVID. And you'll see in this data set, I have some pretty typical data that you would expect here. I have like a province or state, a country, and here there's for a specific time, for a specific date, I have the confirmed number of COVID-19 cases and if there were any deaths in that region as well. So that's the basics of what this data set is. Let's bring it a little bit closer to home here. I live in Washington State, in King County, Washington State. And so if I run a query to say, hey, show me the confirmed cases and deaths over time, just for my state of Washington in my county. Of course, if you've been using Databricks already, you know that there's built-in visualization functions here. I can come make nice charts out of the queries in line as I run them. And now I've got a chart that's plotted the case counts and the death counts, unfortunately, that have occurred for this global pandemic within my county in Washington State where I live. So let's do something a little bit more fancy. We can calculate the relative cases per deaths per 100,000 people per capita. And so if we normalize these values, it's easier to compare different regions to each other. We're also going to normalize the time series. So because COVID-19 broke out in different areas starting at different times. So if we normalize from a process date of 0, taking that minimum date where it was exposed, and then building up a day number from after that was exposed, we can normalize that time series. After that, we're going to create a fancy chart here. I think you might have already got a sneak peek of it down below. Basically, what's going to show on the screen, this is using some open source libraries that you can come in and check out if you download my notebooks and inspect the code. But it's going to display a heat map of the US that shows the relative cases and deaths per capita of the different areas. This chart will show here in just a moment. And so you can see how this has been expanding. This chart is also interactive. Let me just grab this before it runs away on me. This chart is also interactive, and you can come and adjust the slider that was just present on the screen and come and see through time how these cases have been changing and progressing. So you kind of got a really nice interactive chart Just kind of gives you an idea of what you can make and have available within your notebooks themselves, even without taking it to professional enterprise BI tools like Power BI or so forth. Now we're going to take, let's go back up and look at those queries. The first one took about 7 seconds. We'll look, and this last one for the chart like 18. So let's go up here. This query right here that we ran, the simple sum over time. This took 8 seconds to run. Yep. And hey, what's this little light bulb here? This might be interesting to us. Let's take a peek. If we open up this light bulb, these are recommendations that we make to customers that you'll see shown up here. This says it looks like we can accelerate our queries with Delta. It says our query contains a highly selective filter. To improve the performance of the queries, convert the table to Delta and run the optimize and zorder command. The very things that I just went through in our discussion, this optimize and zorder command. It recommends that we run these to accelerate our queries. So let's give it a shot. This ran in about 9 seconds. So let's come back down here and let's say, okay, let's write this as Delta format. All I did is I'm selecting star from that location, and then I'm saying .write .format Delta. Just with that one word switch, I could say .format CSV, Avro, JSON, Parquet, whatever. I say .format Delta, and I say I can overwrite. And I'm partitioning by the state and saving it into DBFS here. Then I can run the optimize and zorder commands. So this is going to take the table using Delta, and I just have this line right here after creating the table that says optimize this table. I don't have to tell it anything else special. It goes through the files, it looks at how large are those files, and it starts to compact them. It starts to merge those files together to get them in just the right sizes for each partition, right? I told it to partition by a state here, province or state. So it's gonna organize and optimize them in just the right size for more fast and efficient reads. In addition, I told it to zorder right after this. Zorder by a process date. So obviously a process date, a date here is going to be a pretty high cardinality column, and the zorder is just going to order that data by that date for faster access as well. So let's run the same exact query. This is the same query from up above, and wow, that ran in about 0.68. And I continue to run it. I'm probably getting some caching benefits now, but you can see that this is a real snappy query, as it should be. This is a pretty simple, straightforward query. And of course, up above, it was reading from many different files, distributed files, and it wasn't taking advantage of all the extra caching, partitioning, the zorder, and the file compaction that we got from the optimize command. So very easy. You saw how quickly I was able to do that just by optimizing that table and adding that zorder, and I get this query speed up here. Here's the old query right below. Again, this query, same exact query. It was taking near 8 seconds. Let's just run it again so you see it again for yourself. Yep, so here 8 to 9 seconds. So just with a few simple lines, right? I say .write .format Delta. It's working out of the box. No extra configurations needed. And then if I want to enhance that performance even further, I can run optimize zorder, and I achieve this amazing 20x performance speed up. So very easy, very simple, and very quick to do. Hopefully this highlights those principles fairly well. All right, now if that's not enough performance benefits, let's dive into the other component I mentioned I would discuss today, our brand new Delta engine, just announced at Spark Summit, Spark and AI Summit. If you didn't watch that just a few months ago, I encourage you to go watch, listen to the keynotes delivered by Ali and Reynolds about Delta engine. Really important and amazing things that were brought up in those sessions. So before diving in, I want to first discuss the motivation behind developing Delta Engine, because this is a serious investment and differentiator for our customers, so I want to highlight why it's important. When developing software, it's important to deeply understand hardware and the trends of where advancement is happening to ensure your software will keep up and capitalize on innovation. Looking at a few different dimensions in hardware trends shows 10x improvements for networking and storage performance, but CPU clock speeds have remained the same. We know that CPU performance isn't stagnant overall, so where are the latest CPU innovations going? These are going into, first, expanding SIMD register width, which allows an instruction to be executed on multiple data points simultaneously, and instruction level parallelism. This allows multiple instructions to be executed at the same time. So to take advantage of this future direction of hardware innovation, I want to introduce you to Delta Engine. 2020 is a huge year for Azure Databricks. Not only do we get the incredible benefits of new Apache Spark 3.0. I'm not even touching all the amazing new features and things that come with Apache Spark 3.0. I don't have enough time in this session. Please go watch in Spark and AI Summit some of the highlights on what's new and important for Spark 3.0. But even beyond and in addition to Apache Spark 3.0, the Delta Engine builds on top and extends Spark performance to a whole new level. It is 100% Spark compatible, maintaining easy portability of your code with no lock-ins, and Delta Engine is composed of three main components. It has an improved query optimizer, some new Delta caching, and coming soon in 2021, there is a native execution engine that we call Photon. I'm going to dive into each of these components and tell you a little bit about them. All right, the first one, the Delta Engine's new improved query optimizer, extends the functionality already in Spark 3.0. Some of these things like the cost-based optimizer, the adaptive query execution, dynamic runtime filters. It adds on and extends these functionalities with more advanced statistics, and we've measured that it can deliver up to 18x increased performance in star schema workloads. The next, Delta Engine's caching layer automatically chooses which input data to cache for the user, and it transcodes this data along the way in a more CPU efficient format to better leverage the increased storage speeds of NVMe SSDs. This is really important, that transcoding aspect that doesn't happen in the normal caching. This alone can deliver up to 5x faster scan performance for virtually all workloads. And the last and maybe most important here is the Delta Engine. In Delta Engine is Photon. We have completely rewritten the Spark execution engine in C++ to maximize the performance improvements of modern hardware innovations. Under the hood, the thing that used to actually work out your queries and turn it into RDD code, which turned it into Java bytecode, this thing that took a load of data frame API transformations actions and turned it into Java to run in a Java virtual machine. Instead of being run in Java, this is C++. Think about what this means. Python, R, these things don't natively run in a JVM, which means you need an interrupt to go back and forth between a Spark engine. Now they're natively running in the same box with Spark, and it is going to be really fast. In fact, we have measured some of this performance, and an independent analyst firm has run a 30 terabyte TPCDS benchmark. And you can see over on the far right, we start with open source Delta Lake with Spark 2.4. Using that as a relative point there, you move on over to the middle and see open source Delta Lake with Apache Spark 3.0. Just changing from Spark 2.4 to 3.0 gives you about 2x improvements. And then if you use Delta Lake on Azure Databricks with the Delta Engine built in, that again leads to near 2x improvement alone, no extra configurations needed. Now the Photon engine, which is coming in 2021, we've already measured the benchmarks here, and you can see near 4x improvement even beyond what we've achieved with Delta Engine on Spark 3.0. This is really exciting stuff, and it's really exciting to see what the performance benefits will bring in the future. All right, now I just want to recap a couple of the main key takeaways that we learned from this session. First, if you're looking for the fastest, highest performance way to process all of your big data analytic workloads, think no further than Apache Spark. In addition, when you're using Apache Spark, you can take advantage of the open source Delta Lake technology. This is open source and portable across any services or products that are using Apache Spark as well, so you're not locked in. Then, if you want to extend your performance even further beyond that, you can use Azure Databricks with the built-in Delta engine, which we went over the benefits, extends the performance even beyond what we get with Apache Spark 3.0 and Delta Lake together. You come and try this out for free and see how it works for yourself. There's a quick link there that you can use on the slide. And if you're already an Azure Databricks customer today, this is available to you for free. No additional configurations or setups needed. Just use the Databricks Runtime 7.0, which includes Apache Spark 3.0 and the Delta engine, and you're off and running with all of these new and exciting benefits and innovations that we just shared with you here today. So with that, I'll sign off. Thank you, and I'll see you on the next one.